Hey everyone. So in this session, we'll see the verification of convolution properties. What are the properties of convolution, by the way? So linear convolution. Okay, the properties for linear and circular convolution are very similar, and they hold good. So which are those properties? One is this property. What do we call the commutative property? If at all we take the sequence one convolute with sequence two. That means say x1 you convolve with x2 and x2 you convolve with x1. Both of them are going to give you same results, right? So 1 plus 2 is equal to 2 plus 1, right? What's the big deal? But 1 minus 2, is it equal to 2 minus 1? No, right? So not all operators satisfy this commutative property. Convolution does. Okay, that's why that's the first property. Which is the second property? So second property is the distributive property. So here it is. If at all you have some x1 plus x2, add them together, then you convolve with x3. So it's going to be same as x1 individually convolved with x3 plus x2 individually convolved with x3. You can see here compared to this particular method, this method is going to save you a lot of multiplications and additions, or I should say MAC operations, right? It's one magical bracket that solves most of your problems. So that's the second property. Then what is the third property? Then there is this associative property where what we will do is we'll have x1 convolved with x2 and together the result convolved with x3 is going to give you x1 convolved with x2 convolved with x3. That's the third property, associative property. Okay. So to verify these three properties, what we are going to do is first we are going to make sure that since we are doing the ready function convolution, right? Uh, we are going to make sure that since there are additions involved and they are matrices, right? They are vector arrays. So we'll make sure that all sequences x1, x2, and x3 in consideration are of same length. Okay, that is one tiny thing we'll take care. And the second thing I have written is zero pad inputs to maximum sequence length in case it is necessary. Okay. Okay. So here we'll see we'll take three sequences, right, to verify the the associative and distributive properties. So what we will do first, we will have give the proper names for x1 convolved with x2. Here I have given it, and x2 convolved with x1, and the trick here, what you should be doing probably is, plot it. Either you can plot it, or what you can do is, let me show you a better program here. Wait a second. Yes, okay. This is a better program, I guess. Okay. So here you can see what you can do is you get your first result x1 convert with x2, then get x2 convert with x1, and then afterwards you can use the if statement here. If both the answers match, then it will display that the commutative property is satisfied. If the answers do not match, then you display commutative property not satisfied. Okay, that's that. And you can see how cleverly a subplot has been used. So because I'm just going to display the results on either sides so that you can just see it for yourselves. But while doing plotting the results, I am not taking into consideration about x-axis or anything, just a graphical representation, and more stress is given on this if-else statements. Okay. The second is the which is a distributive property. Here you can see how cleverly the thing has been named. Okay, x1, x2, x3, right? x1 plus x2, then convolved with x3. So it is a convolution of x1. So you can see this is x1 plus x2, right? So a good programming is all about giving proper variable names, which you and I, both of us, understand. Okay, now here I'm depicting. Otherwise, a good program, as a program, I should have written a nice comments here. You can see x1p x2 actually means x1 plus x2. Then x1p x2 x3 is a variable which is nothing but convolution of their sum with the x3. Okay, and this is the other case where individual convolutions have been taken and then they have been added. Okay, then they have been added. Okay, so you can see, and while because of this, you can see one thing. Let me tell you, things could have gone wrong. See, since I am adding the two arrays here, you can see x1 x3 is an array, x2 x3 is also an array. Luckily, both of them, since I had chosen all three arrays x1, x2, and x3 of same length, both of them were turned out to be of same length. If at all you are given length of first sequence is 3, length of second sequence is 5, length of third sequence is 9, then probably you would have got some matrix errors. Okay, that's why keep that one thing in mind while doing this verifications. Okay, you take all sequences with uniform lengths. Okay, here also you can see how if statement has been used cleverly. Here distributive is the name I gave for x1 is 3 plus x2 x3, the convolution. Okay. Similarly, there's a third one for the associative property. Okay, so now what I will do is let me run this thing. Wait a second. Just give me a moment. Okay, so now I put the run command, enter the first sequence. Let me uh, choose 1, 2, 3, 4. And simple sequences. Sequence again. Wait a second. Okay. Then the third one. Then just taking the scare, to give sequences of uniform lengths, white triple. Okay, and you can see anytime this little sluggish. My laptop is. So there you can see the three display messages have come: commutative property satisfied, distributive property satisfied, associative property satisfied. And then I had thought of plotting this uh, figure. Can you see the figure? Wait a second. A new share. Let me go to this figure file that has popped up here. Okay. So I thought of displaying this particular figure file here. Okay. So in case uh, the x-axis, by the way, I did not take much care to make sure that it starts from 0. Okay, and care has not been taken about the starting point of first sequence and starting point of second sequence. But then, and just you can see they look similar. Okay, they look similar, but the if else approach was much better. Anyway, you can see why semi subplot was used. 3 comma 2 comma 1, 3 comma 2 comma 2, 3 comma 2 comma 3, right? So three rows and two columns, and we could plot them individually, give them legends. Okay. So just be comfortable in these things and all, plotting, giving legends, and titles and all these things. Okay. So that was verification of uh, properties of convolution. Okay, so let me stop here. So something similar you can try for circular convolution also. Something similar you can try for circular convolution also with CCONV command. Okay, thank you.